Hello guys, welcome back to my channel. So today we're working on isoperimetric problem, which is the same thing as Dido's problem. So here, we've been solving problem using Euler's Lagrange equation, and then problem is just boundary value problem. And when I say boundary value problem, what I just mean is that you're given a question and then you have boundaries. Let's say y of 1 equals 0, which implies that your y equals 0 and your x equals 1. So I've explained all these kind of questions using under calculus of variation. So today we're working with isoperimetric problem. An example under isoperimetric problem is Dido's problem. So there's supposed to be a graph before this, but let me just go straight to the point. So what we're doing on Dido's problem is we're going to extremize the functional this subject to the constraint. Anytime I'm talking about isoperimetric problem, what we're just doing is that we have a functional and then we have boundary problems. Also we have what we call our constraint, like a condition. Now if you want to solve anything on isoperimetric problem, what you just need to do is that ensure you have your functional, you have your constraint. So then we can introduce another functional called h. This functional is f of x comma y prime. Those that have been watching my videos will understand what I'm saying, and if you are new, welcome. Please do subscribe. I'm sure you are going to enjoy the videos and the explanation. So here, this is f of x comma y prime. That means it's a function that is a function of x comma y and y prime. So and then your constraint, let's say we have a constraint to be g of x comma y prime. So we introduce another function h of x comma y prime, which will be equal to your function f plus your constraint g multiplied by a constant called lambda. So we'll also, now what you need to understand under isoperimetric problem is that you have to look for three things. That is it. Like, and just give you what you need, what is very important for you to know. I'll also solve a few questions after this video for you to get updated when I upload the videos. Kindly subscribe and then turn on your notification bell so you get updated immediately I upload the next solution under questions on the isoperimetric problem. So what you need to know is that you need to just look for your lambda. I'll explain how to look for that. Then when you get your general solution, let's say you have y equals to ax plus b, for example, then you need to look for your constant a and your constant b. So you see, you're looking for basically three things. It can be more than three, but then note that you'll be looking for your constant lambda subject to your constraint. Then you also look for your constants a and b, or let's say you have three other constants, but then note that you need to look for your lambda and two other constants. Now looking at this, I said extremize this functional subject to the constraint this. So that means I'll say it implies that that means my f equals y, my function equals y, and my g, which is my constraint, equals this. Now if this is equal to this, then I'll write this h, I'll introduce my function h to be equal to this. Now I'll then optimize. So now I'll optimize. So if you want to solve this, you have to use the Euler's Lagrange equation. But you know what? This is our I of age. This is a functional. I explained this already. So then the Euler's Lagrange equation, the first Euler's Lagrange equation is going to change to d dx of di h di y prime minus di h di y equals 0. So here, since you know this is your h, right? Then I'll do di h di y and di h di y prime. So what is my di h di y? Since this is my age, right? This is my age. So my di h di y will then be equal to that means you are differentiating partially with respect to y. So that means I have this one will just be 1. Then here it's going to be automatically 0 because you don't have anything that is depending on y here. Then the next thing is di h di y prime. Anything that is not y prime here will be taken as a constant. So my y is 0. Then this one I'll have lambda. I've explained how to use product rule, anything calculus, elementary calculus under my videos. So if you're having little issues on elementary calculus, you can just try watching few videos I've uploaded before for you to understand better, but then I'll still explain here. So you bring down the power. This is 1 over 2. You differentiate the bracket, so you have 2y prime. You repeat the bracket, 1 plus y prime squared, and reduce the power by 1. So half minus 1 is minus half, so I have 2 to cancel this out. So it implies this equals lambda y prime over 1 plus y prime squared, everything raised to power half. So that is that for my di h di y prime. Now I'll put it inside the formula. So I put inside the formula, I'll have d dx of di h di y prime. What is di h di y prime? This, right? Minus 1 equals 0. And if I take 1 to the other side, I'll have 1. Now for me to integrate, I have to separate. So that means I'll have d of this equals the x, because the x times 1 is the x, right? So if you integrate dy, what will you have? You have y. If you integrate dx, what will you have? You have x. So if you integrate your name, for example, that's lame though, you have what? Your name back. So that means if I integrate this d of this, I'll have this back. That's why I have this back. Then if you integrate x, dx, you have x plus your constant k. Now the next thing is, you cross multiply. So you have my lambda y prime equals this. Now after cross multiply, don't forget, I've already explained countless times that you're always looking for your y, right? So you look for a way to reduce anything y prime and all. Notice that here you have your y prime squared to be inside a cage, which is half, right? So you kind of look for a way to cancel out the half. So if I want to do that, then I'll have, if I have to square both sides. So if I'm squaring both sides, I'll have lambda squared y prime squared equals this squared, and then square we cancel. You know, this is half times squared, you have raised to power 1. So then I'll have lambda squared y prime squared x plus k all squared plus, that means I'm using this to open the bracket, so I'll now have plus y prime squared x plus k all squared. Now I'm looking for a way to factorize y prime squared, right? So all I have to do is take this to the other side. So I have this equals x plus k squared. Then I can factorize y prime squared out. So if I factorize y prime squared, I'll have this. Then I divide both sides by this, right? Then I have this. So for me to get y prime, this y prime is having squared, so I have to do the opposite of square, right? So that means I'll do the square root so that y prime will stand alone, and I have y prime equals square root of this, and then no square will cancel square roots, so I'll have y prime equals x plus k over everything, the down part, the denominator raised to power half. So if that is the case, then I can write that y prime, I can write this back to be in form of dy dx equals this, so that I'll be able to separate and integrate. So then I have dy equals this dx. Now if I integrate dy, I've explained before, you have what? Y. Now integral of this. So look at the notes I wrote here. Anytime you have integral of y over k squared minus y squared, either you let your y equals whatever constant you have here, sine anything, sine t, sine anything you want to use, just that you have to change it back to the normal form later on after you're done. So now I'm letting x plus k. Normally you don't have to show all this solution, because immediately you integrate, you should have this back. That is what anybody will want to see. But then for me to explain to you, you have let x plus k equals lambda sine theta. Then if I differentiate this, the x differentiate constant, you have 0, so that's why I have the x equals to lambda cos theta, then theta. So now I'm done with, I'm trying to change everything, right? So I already have the x, I already have the numerator, so the remaining the denominator, and the denominator is lambda squared minus this squared, everything raised to power half. Now I want to change everything to be in form of cos. So then I have this to be lambda square minus, what is your x plus k? Your x plus k is lambda sine theta, so I have lambda square minus lambda square sine square theta, everything raised to power half. Then I factorize lambda squared out, so I now have 1 minus sine square theta. And you recall under trigonometry that your that your cos square theta plus sine square theta equals 1. So if I have cos square theta plus sine square theta to be equal to 1, then it implies that 1 minus sine square theta will give me what? Half, right? So it will give me cos square theta. So I now have lambda squared cos square theta raised to power half. You know, square, the square root will cancel your square, then you have lambda cos theta to be equal to this. So take note. Now that is why here I have this y equals lambda sine theta, y equals lambda sine theta over, what's this, lambda squared minus x plus k all squared per half. We said is equal to lambda cos theta, right? So lambda cos theta multiplied by lambda cos theta d theta. So this will cancel this out. I'll be left with lambda sine theta. So if you integrate sine theta, lambda is a constant, you bring lambda out. So if you integrate sine theta, you have minus cos theta, then plus your constant of integration. So you recall that I said lambda cos theta equals to lambda squared of everything here, right? So I'll now say it implies that my y equals this plus k. Then I take k to the other side. I have y minus k equals this. Then I square both sides. So this minus is like minus 1. If you square minus 1, you have what? 1. So that's why I now have y minus k squared equals to lambda squared minus x plus k all squared. Now I take this to the other side. I have this equals lambda squared. So which is a what? A circle. So that is the solution to that problem. I'll be solving more questions or more exercise on isoperimetric problem, which I'll be uploading soon. If you really do enjoy this video, do subscribe and then like my videos. Thank you so much and have a nice day.